Being able to rearrange equations is a really important skill in this subject. So I'm going to give you or remind you of the two main rules that you have to remember when you're doing calculations and rearranging equations. The first one is that if you're given an equation and the thing that you actually want to calculate is not the subject of the equation, so it's not the one that says this equals something else, then you need to work out which one you want to make the subject and aim to get that on its own. And when you've figured out which variable it is you want to make the subject, which one it is you want to get on its own, then you have to just remember that whatever you do to one side of the equation, you need to do to the other. So I'm just going to go through three small examples. The first one, we're going to start with A on B plus C equals 5, and we want to make A the subject. So first of all, we want to make the A, get the A on its own, so we need to get rid of the C from this side of the equation. So if it's added here, we need to subtract it from both sides. So we'll say A on B plus C, subtract the C from that side, and we also need to subtract the C from that side. Of course, plus C minus C, they cancel out. So we are left with, that looks like a D, A on B equals 5 minus C. To get the A alone, we would need to get rid of that B. And because it's B is it's A divided by B, what we need to do is multiply both sides by B. Of course, this side you need to treat as if it were in brackets. Okay, divided by B, multiplied by B, they cancel. So we have A equals 5 minus C times B. The next example is using a trigonometric function, sine. The sine of an angle is 0.5, and we want to find that angle. So what we need to do is to get that angle on its own, and it's being operated on by a sine. So what we need to do is do the inverse of that. We need to operate on that with an inverse sine. So inverse sine of that whole thing. But we need to do it to both sides of the equation. This essentially cancels, so we're left with theta is the inverse sine of 0.5. And if you put that into your calculator, you'd find that would be 30 degrees. Okay, the third example here is for this equation here. It's the potential energy stored in a spring is 1/2 times the spring constant times the extension of that spring to the power of 2, so extension squared. And we want to make x the subject. I like to have the thing that I want to make the subject, I like to start with it over on the left hand side, so I'm just going to rearrange this. 1/2 kx squared is the potential energy. I haven't done anything really to it, I've just swapped the sides over. Right, I'm trying to get the x on its own. So what I could do is try and get rid of this half, so I could multiply both sides of the equation by 2. Alright, that 2 would cancel with a half, and I'd be left with kx squared is 2ep. I want to get the x on its own, so if I divide both sides by k, those k's cancel, so we'll be left with x squared equals 2ep on k. I need to get the x on its own, so if the square root of both sides, the square root cancels out the square, so I'd be left with x equals the square root of 2 potential energy divided by the spring constant. And there we go. That's an equation that gives the extension of the spring as a function of the potential energy of the spring and the spring constant. So those are just 3 examples. Some of you are going to feel a lot more confident than this than others. It's just a matter of practice. It's a matter of knowing what you can do to both sides of the equation, what the order that you need to do it in, and it just takes practice, practice, practice. And then it will become second nature.